You see that line right there? That jagged little grin on the side of this manifold? That's the face of a ghost that's come back to haunt me from 1954.
It looks like it's barely holding on by a thread, Tiger. Or, well, by a molecule of carbon. Does everything in this shop have to be a relic, or can we just buy a new one?
By new, Alex, we're in the business of resurrection. But today, we're talking about the one material that makes every welder in a 5-mile radius suddenly remember they have a dentist appointment. Cast iron. It's the crankiest, most stubborn metal in the bin. It's got 10 times the carbon of regular steel, which basically means it has the personality of a dry cracker. You look at it wrong and it snaps.
I've heard the horror stories. People say you can finish a weld, walk away to grab a sandwich, and hear a ping from across the room that sounds like a tiny gunshot.
That ping is the sound of your weekend dying. It's the sound of a stress crack traveling through your hard work because the metal cooled down faster than a New York minute. It's why most folks just throw these parts in the scrap heap. But if you understand the metallurgy, the way those little flakes of graphite are just waiting to ruin your day, you can actually tame it.
Okay, let's get into it then. If I'm looking at a piece of metal, how do I even know it's cast iron? I mean, besides the fact that it's probably attached to something ancient and heavy.
Good question. Cast iron has this dull, grainy look when it's fractured. High carbon, roughly 2 to 4%. That's the culprit. In white iron, that carbon stays locked up, but in the gray cast iron we usually see in engine blocks or old machinery, it forms these little graphite flakes. When you heat it up with a welding arc, those flakes move around and get cozy with the iron, and when it cools, it turns into something about as flexible as a frozen Snickers bar.
So it's basically a metal that hates being hot and hates being cold. That sounds like a fun Saturday. Where do we even start?
First, you got to clean it like you're prepping for surgery. Cast iron is porous. It's like a sponge for 60 years of grease and oil. If you don't grind out the crack and get down to bright, shiny metal, your weld is going to look like a tray of burnt brownies. I usually take a die grinder and V out the crack, then maybe drill a tiny hole at each end of the fracture just to tell the crack, hey, you stop right here.
Like a fire break in a forest. Smart. But then I see people putting these things in ovens. Are we baking a cake or welding a part?
Well, you have two schools of thought and they're both valid as long as you don't try to play both sides of the fence. Method one is the sauna treatment. You preheat the whole casting, and I mean the whole thing, not just a corner, to somewhere between 500 and 1200 degrees. You want it roasting, but don't cross 1400 or you're inviting the devil to dinner.
1400 is the critical temperature, right? Lincoln Electric says that's where the real structural weirdness starts happening.
Exactly. You keep it in that Goldilocks zone so the temperature difference between your weld puddle and the rest of the part isn't so violent. It's like jumping into a pool. It's easier if the water's been sitting in the sun all day than if it's fresh off a glacier.
And the second method, for those of us who don't have a massive industrial oven next to our drill press?
That's the cold turkey method. You keep the part cool, not refrigerated cool, but touchable cool. You do a 1-inch bead, then you stop, you go have a coffee, you watch a bird, you wait until you can put your bare hand on that weld. You're trying to prevent the heat-affected zone from getting so big that it pulls the rest of the metal apart.
Wait, 1 inch at a time? This manifold represents about 12 hours of bird watching then.
Pretty much. And while it's still hot, you do what we call peening. You take a ball peen hammer and just lightly tap on the weld bead. It's like massaging the stress out of the metal. You're physically stretching the weld while it's ductile so it doesn't shrink and pull a crack right down the middle as it cools.
You mentioned admixture earlier. I assume that's why we can't just use the same cheap 60-10 rods we use for the garden gate?
Heavens no. If you use a standard steel rod on cast iron, the weld will pick up so much carbon it basically becomes a file. You won't be able to drill it or grind it, it'll just laugh at you. If you need to machine the part later, like if you're fixing a hole someone drilled in the wrong spot, you need a high nickel rod. Tech Rod 99 is nearly pure nickel. It stays soft and clickable even after it cools.
Nickel's expensive, though. I saw the price of those rods and almost dropped my coffee.
It'll make your wallet light for sure. That's why some guys use Tech Rod 55 for the fill. It's got a bit more iron in it, still good, but a little easier on the bank account. If you don't care about machining it, say you're just fixing a crack in a heavy base for a drill press, you can use something like Ferroweld. It'll rust just like the iron, so it blends in, but it's brittle as glass.
And what about the actual process? Stick is the classic, but I see people using TIG or even MIG with flux core. Is there a best way, or is it just whatever is already plugged in?
Stick is the old reliable because you can swap rods easily and the flux helps keep that puddle clean. But TIG is great if you want surgical precision. I've seen guys use a silicon bronze rod and do what's essentially a high temperature braze. It's not technically a fusion weld in the same way, but it sticks like a bad reputation and doesn't require as much heat, so the casting stays happy.
Sticks like a bad reputation. I'm stealing that. But let's talk about the aftermath. You finished the weld, you've hammered on it, you've been patient. Now what? Do you just set it on the bench and go to bed?
That's the fastest way to hear that ping we talked about. You have to tuck that part in. I bury mine in a bucket of dry sand or wrap it in a heavy welding blanket. You want it to take all night to get back to room temperature. It's like a slow-cooked brisket. The longer it takes, the better the result. If you let the air hit it and cool it too fast, all that stress you tried to manage is going to snap that metal like a dry twig.
I saw a video of a guy named Brandon Lund using Muggy Weld. He did an exhaust manifold with no preheat. Is that magic or just really good marketing?
It's good chemistry. There are specialized rods designed to work at lower temperatures with high moisture-absorbing flux. They're great for in-the-field repairs where you can't exactly drag a wood-burning stove out to a tractor in a muddy field. But even with the fancy stuff, the rules of physics still apply. You're still walking a tightrope between heat and heartbreak.
What about the other problem metals? We've beaten cast iron to death, but I know you've had some legendary scraps with some other alloys.
Don't get me started on pot metal or white metal. It's the stuff they make cheap carburetors or door handles out of. It's essentially a soup of zinc, aluminum, and whatever else was on the floor of the factory that day. You hit it with a torch, and it doesn't melt. It just turns into a puddle of gray slush and disappears into the floor.
I remember the time you tried to weld that vintage hood ornament. I think you actually apologized to it afterward.
I did. It just wilted like a salted slug. For metals like that, or even some high magnesium alloys, you're often better off using specialized brazing rods that melt at a much lower temp than the base metal. It's more like gluing with molten metal.
It sounds like the common thread here is that you can't treat every metal like it's a piece of 1/4-inch angle iron from the big box store.
That's the secret, Alex. Steel is forgiving. Steel will let you be a little sloppy and still hold a trailer together. But cast iron demands respect. It's got a long memory. If you rush it, if you get impatient, it'll wait until you're almost done and then fail just to spite you.
So, for the folks listening who have a cracked wood stove or an old engine block staring at them, what's the one thing they should keep in mind before they strike an arc?
Clean until it shines, then clean it again. And decide on your strategy before you start. If you're going hot, go all the way hot. If you're going cold, be the most patient person on earth. Don't change your mind halfway through. Once you commit to the sauna or the walk, stay on that path until the part is buried in the sand.
Patience and nickel. Sounds like a recipe for a long afternoon.
It is. But when you pull that part out of the sand the next morning, and it's one solid piece again, and you hit it with a grinder and it doesn't crack, that's a feeling better than a winning lottery ticket. You've outsmarted the physics of the 19th century.
I think I'll stick to woodworking for today, Tiger. No pings and a dovetail.
Just wait until the humidity hits them, Alex. Everything's got a way of moving on you. But that's a story for the next cup of coffee.
Transitioning to the takeaway, what's the big lesson here for the makers?
Don't be afraid of the problem metals. They're only problems if you try to force your will on them. Listen to what the metal needs, whether it's a slow cool down or a specific alloy rod, and it'll work with you. A successful repair on an unweldable part is what separates a trigger puller from a true craftsman.
Spoken like a man who has paid his dues in burnt sand and expensive nickel rods.
More than I care to admit, Alex. More than I care to admit.